Welcome to Elixir Wizards, a podcast where we talk with software developers from around the world about the Elixir language and other modern web technologies. My name is Justice Epen, and I'm your host today, a developer at SmartLogic. That's a Baltimore-based consulting company that has been building web and mobile applications since 2005. I'm joined by my colleague, Eric Ostrich, the fellow wizard. Eric, say hi.
Hello.
And our theme this season is working with Elixir. So we're talking with our guests on various aspects of working with Elixir, from performance to functional programming to hiring and training. And today we're joined by the famous, rightfully so, the famous Chris Keithley. He works at Bleacher Report and on the Elixir Outlaws podcast that you've probably heard before. He's one of our favorite guests on the show. Keithley, how are you doing today, man?
I'm good. I'm great. How are y'all?
We're doing so good. Now, what is Norm and how is it going?
Yeah. So Norm is a project I've been working on off and on for a while. And then, recently, kind of been more in earnest. But Norm is sort of the thing that I've been wanting in Elixir for a long time, is like a replacement for, I don't know, in some ways a replacement for Dialyzer, a way to describe data moving through your system. And that's basically what it does. It allows you to build contracts internal to your application for the data that's like moving inside your application. And it does that in some very specific ways. It's very open, is the way I like to describe it, meaning a lot of the systems that people use to build contracts to sort of enforce that, like, they're getting the stuff right, like they're passing around the data that they mean to be passing around. It does a bunch of things and a bunch of negative things a lot of times. Like, it does validate stuff, and that's good. But a lot of times the systems that people use have these knock-on effects where they create a lot of additional coupling. They create a lot of coupling between call sites, and they also create a lot of rigidity in your system, meaning it's much harder to grow that system over time. And I feel like one of my goals in work and just as a programmer is building systems that are robust and, do the things they need to do, but are able to grow in the future as well. And so Norm is specifically designed to be open in that way. It's open to change in the future. And it's specifically designed to allow you to grow a system over time, which means the trade-off being we're not going to tell you as much stuff is wrong, although we'll tell you more stuff's wrong than Dialyzer will, and like much more interesting stuff than Dialyzer could, or any type system could. But, the trade-off being that it doesn't catch everything. We're going to be more permissive about certain types of things. But overall, it's going well.
And this is a replacement for Dialyzer, or will they play well together? Or
you can certainly use both. Yeah. I mean, if you like Dialyzer, all 5 of you out there, then keep using it. It's great. It's probably doing what you want it to do. For me, it can't replace Dialyzer because I don't use Dialyzer to begin with. So there's no replacing it. This is sort of orthogonal. And I would say, if you're looking at it from the point of view of I want a type system, I want a type algebra that I can then prove things, it's not really going to do you that. If you want compile time checks, you could build that with Norm, and Norm would allow you to do those kinds of things. I'm not interested in that, mostly because I'm not interested in proving things. That's interesting. I'm glad someone's interested in that. But for me, in the work that I do every day, that's just not what programming's about. Programming's never been about proving your initial propositions matched with your whatever. This is super not interesting to me as a thing. It doesn't help me in my job any more than this helps me in my job. And actually, this helps me say much more interesting things.
And is it ready for anyone to pick up out of your GitHub and start using?
Oh, yeah. Yeah. It's in a really good spot at this point. It's one of those things I feel weird talking about it this way because it sounds like I'm shilling for it, which I mean, I am to some degree. But I have lots of open source libraries, almost none of which I'm that's a good thing. You should use that. I don't a lot of the majority of my open source projects. I feel have these big problems with them, or now, but I'm tied to it or whatever. Where Norm, I actually think I got kind of the core of it right. I think I'm actually pretty happy with where it's at, and I think if you pick it up now, there was a sort of a recently I made a somewhat substantial change to the way that schemas and the way that you define optionality around keys inside of a schema. And that, landed a little bit ago. And I think after that change, there's really no more major things that are going to ever change about it. We'll probably add new things. Specifically, we're adding syntax so that you'll be able to define something that looks like a type spec above your functions. And it'll actually automatically validate the inputs and outputs conform to the specifications that you've that you've described. So you get guard, like essentially superpowered guard clauses in and out of the function. That's coming. There's PR open for that now, but that'll be the last like sort of major feature that's added to the library.
That's super cool. Yeah, we have at ElixirConf this year, you showed, at least as part of it, Norm off in that. So we'll make sure to include the link to that so you can watch the whole talk. So what was your first introduction to functional programming, since that's kind of what this theme is for this season?
So my first like real intros to functional programming, I'm trying to remember the exact timeline. I was thinking about this earlier. It's either Haskell or it's Clojure, which are two very opposite ends of the spectrum. It might be Clojure. I think it's Clojure was my very, very first, like if I'm going back to it. And at the time, I completely dismissed it because I was sort of like, I don't know. I never really got on like the object-oriented train. Like I came out of C. I came out of like a very procedural set of thinking, but like I dismissed Clojure pretty quickly, largely because of the parens and partially because of the immutability and some other things and just youthful ignorance. I now realize like how big of a miss that one was, where I'm like, could have discovered Clojure like 5 years ahead of time or whatever. But yeah, so I think that was it. Did some Haskell, did a little bit of Haskell. Never really, I still use Haskell for prototyping occasionally, but never really got into it. And then Elixir. And Elixir is sort of like a functional-ish language, right? Like it's like a mongrel language of all kinds of things, mostly because Erlang's not really a functional language. It's in the traditional sort of sense of it, but I think it makes the appropriate trade-offs. It has all the value adds, like it has all the things you actually want in a functional language, which is to say like first-class functions, immutable data. That's like really it. Like if you have those things, that's all the value adds that you want.
I guess I'm curious because we've been talking a lot about functional programming on the show, and I think that what people probably want to hear from you. I mean, I imagine somewhere in your brain you have like a hot take on functional programming that everybody is just dying to hear, but I don't know how to dig it out of you without just telling you explicitly. Like, give us the hot take on functional programming, Chris.
Oh, so I think most people, when they talk about functional programming, they get something very like they get a distinct picture in their mind, right? And I think for most people, it's probably something in the shape of Haskell. Like I think a lot of people come into this world and they look at Haskell as this sort of like platonic ideal thing, like that is functional programming, which is to say like statically typed, immutable data, equal signs, that means assertion on functions and pattern matching. Like that's like what it is, right? And if I have a take at all, which I'm not sure that I do necessarily, but I think the majority of benefits you get from functional programming are fairly modern. And the modern things are like a decent concurrency story, first-class functions and immutable data. And immutable data and first-class functions really are everything that you need. And that's where all the value of functional programming is. And that's a fairly modern view of functional programming. Like most functional languages in history have not had immutable data. I would say the majority of them, if they have had immutable data, all the data structures have been crap up until Clojure, and which is really the language that I think proved that you could do it wholesale, like everything is immutable and everything is ergonomic, and no other language comes close to that. And I think that's where all the value of sort of this modern, new wave of functional stuff is that's where all the value is in those data structures, and is in immutable data and is in first class functions. And, if you can layer a good concurrency story, be it actors or CSP or whatever, on top of that, you're in really, really good shape.
And can you talk maybe a little bit about like relate that back to Elixir? Because I don't think, does Elixir actually do those things to the degree, I mean, certainly not to the degree that Clojure does. Can you talk a little bit about that?
I think Clojure is, in many ways, like, I don't know, it's about as close as you can get to an immaculately designed language. Like, I mean, just like the core of it is really good. It's a really good design. And, say what you will about Lisp, say what you will about the language itself, like all these other things, like, and there's obviously, nothing's perfect, right? There's all kinds of stuff in there that I'm sure that, people who use it in anger don't love or whatever. But I think you have to look at Clojure as for what it is, which is like a very, very well thought out, very holistic design. And unfortunately, Elixir is transparent enough over the top of Erlang that we're beholden to some of the sins of Erlang, which were trade-offs made for purpose, right? Like they're trade-offs made to make that system run in the 80s, right? It's like on something like less powerful than this Raspberry Pi over here. So, you have to make these kinds of trade-offs, right? Like, I think if I remember correctly, like Erlang predates all of Okasaki's work on immutable data structures and stuff like that. So it's no wonder all we have is like cons lists and tuples, and like that's it. And you've got to build the world out of those two things. That makes sense because like that's, cutting edge. Like no one knew how to build efficient immutable data structures, like really like get within 2x performance of the mutable ones until Clojure, right? So it's like, and now everybody's like catching up. But so we lack a certain amount of those. A lot of it's just because we want to interop with Erlang. We want to be able to take advantage of all the Erlang stuff. So we're stuck with cons lists forever, despite the fact that they're really kind of a garbage data structure. Why?
Yeah.
I mean, they have terrible characteristics overall, like compared to like the sort of the cutting edge right now for list shaped things, like for list shaped immutable data structures right now is what's known as a RRB tree. Doesn't matter. It's an immutable data structure tree that allows you to approximate a list as a tree. And it has great characteristics. It's like log 64 in. So you need 64 times the amount of stuff in it to like increase another step. So it's like pretty close to like constant time to go get elements anywhere in the vector or in the list. It has very, very highly efficient insert at the end, but you can build them such that they have highly efficient insert at the beginning as well. They split and concatenate very, very quickly. I think it's log n to split them and to concatenate. So they have these great properties that lists just can't come close to. Like there's really no reason. And like the only benefit of having a list to get something really, really fast at the beginning or put something like at the beginning of the list is completely mitigated by the fact that, it's log 64 and like how I would make that trade any day of the week to have all those other properties. There's no benefit. There's no substantive benefit over using a cons list at all in today's language. But we want to interop with Erlang. And so because of that, we need to use lists because they use lists because that's what Erlang talks in for everything. If you had no desire to interact with Erlang, you could totally do it. You could have vectors as like a side thing, but now you're back to this problem of like, you need it to be ergonomic. You need it to be useful, right? And how often do you reach for a map over a map set simply because like you can pattern match on it, right? Or like you can have all these other operations syntactically that you can't use with map sets because they're just like a struct. You can't really interact with them in the same way. And so, because of that, Elixir has to sort of make these trade-offs, right? It has to make these trade-offs because it wants to take advantage of all this other stuff, and it has to interact with the runtime. At the end of the day, the runtime creeps into the Erlang runtime itself creeps up into our user land a lot. I think that's, one of the defining characteristics of the Beam is it leaks a lot into our world. And so, we make those trade-offs, but at the same time, like those are the appropriate trade-offs to make. Like I'm not leaving Elixir, right? Because of it. It's like, those were the right trade-offs to make, but it is like, those are trade-offs that are being made. And it's important to keep those in mind.
So your next library will be creating that data structure that's way faster, right?
I'm working on it. It's been a slow thing just because it's the project stack is a stack, right? Stuff comes on, it goes on the top of the stack, and then you got to work your way back down again. So the vector library is coming. It keeps getting pushed lower down in the stack at the moment.
What about Keithley Lang?
Well, so I did write a very silly like toy language to do all the Advent of Code challenges in. It's not quite done. I'm still working on like the LLVM backend for it. But yeah, that'll, I have no desire to do that. I've seen Jose in person before, and that doesn't look like fun at all. Like having to do the nonsense that he does, like I don't want to do that. It's easier to sit over here in my armchair and critique things from here.
I am a little bit curious about your thoughts on the future in terms of adoption of Elixir and displacement of other very popular languages. My thought process anyway has been that Elixir right now looks a lot like Ruby looked, in the early 2000s. Do you think that we'll see a displacement of Ruby and Rails?
I don't. I just don't. Not wholesale for sure. That work, I don't know. The Rails stuff, it's too commoditized. Like, it's just like too many people know Rails at this point, and it's too cheap to get Rails work done. You think, and it's like, you just have this whole infrastructure around it at this point, around Ruby and specifically around Rails. I think we can all stop pretending that Ruby matters outside of Rails, which, I don't feel like is too controversial a thing to say. It might upset people, but like, I think that's a real thing. Like just historically speaking. Right. And at this point, the people who wanted to make Ruby weird and do other stuff have all left. So, it's like, what do you got left? It's just the Rails.
What do you think it would take?
I don't know that anything can displace something like Ruby, because it's such like a perfect, Ruby's like one of those, like, it's like perfect storm of like right time, right place, right technology, right people who got involved with the project early on. It's just like this like just total building a language that becomes popular either takes a gargantuan marketing effort, looking at Java, or it's like, I'd say it's like catching lightning in a bottle, but it's not. It's like catching lightning in 5 bottles. It's like you have to do so many things right in order, and all these other things that you don't control also have to go well. And so I don't see Elixir doing that, just because like the world has changed. Like Rails exists already, right? So there's no other new thing that can sort of like supplant that. Like the closest thing, and this is a bad example because I don't believe that this will do it, but like the thing that would do it is like universal, some sort of serverless type thing where you don't write a backend at all. That's the kind of technology that would actually displace Rails, because it makes it obsolete. I don't think you can beat Rails by just being better than Rails. Like you have to be fundamentally different. And again, serverless thing is a bad example because I don't think that that's the future either. But like that's the kind of thing that it's going to actually take. But at the same time, like I don't know that displacing Rails should be the goal. I don't know. I don't think about adoption too much because it feels so insurmountable to me that it depresses me to think about it too much. Like, and my tactic for a long time now has just been to, I don't know, like be excited about the language, talk about the language, try to build cool stuff in the language, and let the proof sort of like exist in the world, like build cool things, talk about it, share it with people. And that's the advice that I give to most people who want to see Elixir succeed, is like build cool stuff, show people, don't waste your time like trying to like get on Hacker News or wherever, or Twitter, and already these other garbage websites and like try to talk to people about this. Like just build cool stuff and prove it, like show it. That will do so much more for the adoption, because you don't move the circle by like getting in the middle of the circle and shoving people. You move the circle by building your own circle and being awesome. And everybody will gradually want to be a part of your circle because people want to be part of things that are awesome.
Yeah, I think that's a good approach. Part of the Big Elixir, Brian Cardarella did his keynote on adoption and had some good thoughts there of like Elixir is starting to show up in these numbers don't really mean anything, but like the TIOB index like has Elixir now as part of an up and coming thing. So like the ball is definitely getting rolling. So it's
yeah, and I think making it a safe choice is like good, and you make it a safe choice. So like the thing is, like the world is mostly dominated by pragmatists, by people who make, which is to say, by people who make decisions based on comparisons. Those comparisons are completely arbitrary because choosing the right tool for the job is a lie and has been from the very first time it's ever been spoken by any human being. It's never been a real thing that anybody's ever actually done. It's 100% preference and very small critiques amongst things that you already prefer. The more honest we are about that, the more we can actually sort of like use it to our advantage. Because of that, what pragmatists do is they compare things. And so you have to give them something to compare against. Like if there was no Discord, right? Like if there was no Bleacher Report, if there was no Mux or any of these other companies that use Elixir and have like tons and tons of traffic and all these kinds of other things, right? No one can compare apples to apples. And by apples to apples, you really mean apples to oranges, but you paint the oranges red and you call them apples so that people believe they're making a fair choice, right? Like that's how marketing works. And choosing a language is nothing but marketing.
Yeah, I definitely agree with you on the choose the right tool for the job. It definitely seems like people more likely just grab the closest tool that they have access to that will do the job.
Oh yeah, absolutely. And that's fine. And actually, like, that's reasonable. Like if everyone you employ knows Go already, well then you should like probably write your thing in Go. I don't like Go. I am never going to choose to write Go given the option, but like you run your company, do it however you want to do it. If all your people know Haskell, like you're probably going to be productive. And at the end of the day, like you got to put this junk into production and then maintain it. And most software spends the majority of its life being maintained and not being written the first time. You got to pick the thing you're going to be willing to live with. And that really, at the end of the day, basically comes down to preference.
And for all the smart people, the answer is Elixir.
Well, and that's the thing. I am here to tell you, like, I'm very happy maintaining all my Elixir apps because they take very little maintenance and like very little tuning of things. But yeah, I mean, at the end of the day, you got to pick the thing you're comfortable with, or at least it has been proven to you. Like if you are going to get on a hype train, right, it's got to be proven to you that it's going to work. And some people, cheat, like Go cheats because it's got Google attached to it. And that stupid Gopher wasn't enough to dissuade anybody else that they like had no idea what they were doing. It's a reasonably fast language and like it has, curly braces. So it's like, Alon-Z. You get on board with this stuff because some people like get to cheat like that, right? And like it comes with cred out of the box. And other people, just hate themselves. And so they write Rust. And so, because they just, don't value, they just want to solve problems. And where the problem is, can I make this type checker allow me to compile my code?
So you mentioned tuning in there. So one of the other, tenets of this season is performance. Let's swing around to that real quick before we sign off. So for what you do at Bleacher Report, what is the bar for what you might consider like something is performant?
So for our work, the work that we do, right? I mean, at the end of the day, like let's call it what it is. We're putting, sports news on the internet. We need to be very clear about like the problem space. And because of that, the thing that we're optimizing for is not the same things you'd be optimizing for if you're doing like high frequency trading, right? Like you're like, I don't need to be the first one there. There are a handful of things where we're like, we have to be the first ones there. But by and large, like we're not, trying to eke out milliseconds or microseconds or any of this kind of stuff. Milliseconds occasionally, but microseconds definitely never. Because we're just that's not our thing. In fact, we would actually opt for something to be slower if it meant that we could handle, let's say, 5 times like the amount of users simultaneously. Like it'd be fine for something to go from 20 milliseconds to 50 milliseconds if five times the amount of people could all access it from a single service, right? Like that's a trade-off we would make right now because, that's more meaningful to us at the end of the day. So we approach it from that perspective. Like we're very much in the business of like, we have a lot of users. They tend to stampede to the site all at once, and we need to not go down. We have to serve traffic. And ideally we're serving, not cached live traffic because we're still up and running. So for, the majority of our services, they need to be able to withstand many thousands of requests a second. And ideally, we want to be able to do that on a minimal number of boxes, right? So we don't want to run 30 boxes to serve, let's call it like 5,000 requests a second. Now you're just paying AWS too much money. So we have like some loose targets around that stuff. Obviously, it flexes depending on what needs to happen and different workloads and those kinds of things. But, so that's kind of where we're at, is we're trying to say like, how can we eliminate the amount of boxes we need to run? Because it shortens the deployment time. It makes it easier to deploy all that stuff. It makes it easier to provision all of it. Just simplifies a ton of your life if you can run 3 boxes instead of 10. For a lot of these things, we have sort of like, let's call it quiescent state, like just like steady state, which is like, you need to be able to handle 5,000 requests a second. I don't know, I'm picking a number, right, for some service somewhere. How high are you going to spike? Like, what are your access patterns going to look like? And if, we get let's say like a 10 to 20x like traffic spike over the top of that, can you handle that? Like, are you going to be good? What that really means is like, there's no way you'll be able to handle that. So how do you start to fail? Like, how do you start to blow all the bulkheads in the ship to keep the ship running, just to keep it alive at the end of the day? And so that's typically what we're optimizing for, is like, scalability is all about like, how do you handle things when it fails, right? Because that's the nature of the system, right? Like everything's failing all the time, and it just happens to fail like a whole lot more under high load events. So you have to allow it to continue to just like degrade gracefully, as they say.
Can you maybe dive into, I don't know, some specifics? Like, do you have any stories, especially like around Elixir and sort of implementing it? You've seen at scale, like what it looks like. I mean, we used to ask a question in maybe not the last season, but the season before, we'd ask, like, do you have any stories where Elixir saved the day? And I guess I'm curious if you do.
Yeah, I mean, all the time. And that's the great thing, is like the ability to get more out of these boxes. I mean, it's unlike any runtime I've worked in. Like, this is at the end of the day, like what keeps me around. It's just too easy to sort of get a little bit more mileage out of the box. And it's all like code. Like, it's just like userland code. Like, I've never needed to tune the garbage collector, right? Like, I remember from Java having to go in and be like, what garbage collector are we going to use? And like, how do you give it the right amount of like input and heap space and all this stuff? It's like, the only time I've ever messed with the scheduler flags, I've made it worse. It's like, if you just like stay out of it, it'll do fine. And you can tweak so much in userland. So one example is, we have a front door API, and it talks to a bunch of downstream things, as our front door does. And the typical usage pattern is somebody gets an alert on their phone, and they open up the phone, And the very first thing that they see when they open up the phone is that it in the background, they go to the alert, but in the background, what we start doing is we start fetching their, let's call it their home stream, their stuff, like the set of stuff that they're like subscribed to, right? Well, it turns out that like that's the most high cardinality query that we do for content across the board, right? Because everybody's different. So it's very hard to cache that endpoint. Basically, it's impossible to cache that endpoint. Every single person has a different set of stuff. So you have to cache it like on a per user basis. It's a whole different problem. But what the front door does is behind the scenes, periodically, it actually caches just sort of a generic set of stuff, right? A generic set of things that we could show on the home screen. It's not ideal, but we do that. And we do that in the background. We put it in ETS. And that's the work of 20 lines of code, right? Is to like go and fetch that thing periodically, hydrate it, put it in ETS, and just keep that running. And then as part of that request, I mean, that single request to go hit the home stream is actually probably something on the order of like 6 requests, like to different services to do different things. And if those start to fail, they all start to sort of like gracefully degrade, right? So we have circuit breakers around all that stuff. And if they start to blow, well, we just like start turning stuff off. So we stop making certain calls. And if we can't go get content, then circuit blows and we immediately just fall over to the ETS cache. And then it turns out the ETS cache is way faster. And actually, it alleviates tons of. It actually turns out to like make the box like actually run faster because the CPU is not caught up waiting, scheduling, a million processes or whatever, and it's able to get the processes out of its run queue faster because now it just like is able to go to ETS or whatever. And that's a very common pattern. Like lots of people use circuit breakers, right? Like lots of big, high, large scale services have to use circuit breakers just to keep everybody alive. So this is not revelatory, right? It's not when I bring this up. But one of the things that surprises me continually is that solution, that entire thing, I mean, I wrote it and it took, I think, like half a day. And it's not because I'm a genius. It's because I'm not. I program through sheer force of will and just that's really it. But it's immediate. It's like you're just talking about data, right? You just got data and you've got functions and you just like call the functions with the data and then you get the data back and then you just like do stuff with it. And like, something like ETS, like having ETS there, right? That it exists at all and is in this runtime where it's easy to have a background process just like that you spawn and is like super lightweight and just runs in your front door application and like no one notices because it's doing work, right? You can't do that. You spawn a thread in the JVM and just like let it sit there. It's hogging up, half a gig worth of stack on your box. Like you're not going to do that. That entire solution, I think all told was like less than 100 lines of code. And it took half a day to build it and like that's including testing and like property-based testing. And it's like, I don't know another runtime where you can do that, where that's all it took and it's done. And it was deployed by the end of the day and then now it just works. And occasionally, like, certainly, like, it falls over because that's its job. Like, its job is to be aggressive and to fall over to cache when we need it to. But it's just amazing to me that it's just sat there and done its job since then and, like, hasn't needed to be tweaked or anything. It's like, it's it. It's like this actually, like, fairly complicated set of things it needs to do. And it's just right there and immediate. Stuff like that it's like, that's what keeps me around because it's like, and that's what lets me like sleep at night. I don't ever get paged at night or anything like that because it's like, that stuff's just working.
And I think one nice takeaway from that is like, you could probably do that in like a Ruby or whatever else app, but you'd probably reach for like Redis or Memcache. That's possibly another network request that might.
And now you have 2 problems. Now you got a Redis problem. Yeah.
Okay, so I think our final question is we want to, or I'm curious, like, what do you use to detect that spikes are happening, or like, what kind of metrics are you collecting?
Yeah, so we use a ton of time series. People have different takes on this stuff. I live and breathe time series still. We essentially use StatsD, but only because we vendor all of our stuff through Datadog and we're required to, use their stuff. In the past, I've used like Prometheus and those sorts of things, but but we just use StatsD metrics for stuff. We monitor a lot of it via StatsD. We have different observability tools, I would say. Like we have APM and we have all these we have open tracing and all this kind of stuff to be able to really dig in, which open tracing is pretty amazing. Like I'm pretty sold, or I guess it's called OpenConsensus now or something like that. It's gone through a whole series of changes, and that for observability plus logs and those sorts of things, like those are great observability tools. Like when a problem's happened and you want to figure out why, those are great. But for me, alerting and reporting is that's all the purview of just time series metrics. The important things are we monitor availability where availability is successful requests over total requests. Right. So we don't monitor based on like a time, like how many hours, quote unquote, have you been up or whatever. It's like, so that's not meaningful in aggregate. The meaningful thing is like how many successful requests have you been able to process? Where success is really determined by the endpoint. This is something that most of these like sort of off the shelf APM stats kind of things get wrong, is that what you actually care about, first of all, you never care about the median or the average, which is what they all want to show you, which is garbage and not useful. And then they all want to show you based on like your service, like all aggregate, all endpoints over all your service. And that's like just not accurate. It's not how you actually care about those things most of the time. And so we care about it very much on a per endpoint basis. And we'll determine that based on like if it actually did what it wanted to do and all that kind of stuff. And then we monitor those over a sliding window, but we monitor availability, and we typically do, for like mission critical stuff, we might do like 99.99% of requests need to be successful. For less critical things, we'll do 99.9. For super non-critical stuff, 99%. And so we start to alert if we start to dip below those things. The other real key metric is we really only care about 95th percentile latencies and above. It's not helpful for us at our scale to care at all about like what the average is doing, just because we just have too many requests a second for it to, you get weighted down too much, and all the important, interesting information is out there on the edges. So we really look at 95th and above. Typically the only granularities we need are like 95th, 99th max. And with those three, you're in pretty good shape. Some people, you want to see like 99, 99.9, all that kind of thing. You want to drill farther down into it. But for us, we're really good. The granularities of like 95th and 99th and max are about right. And we'll start to look at those and use those as leading indicators of like what's going wrong. We also monitor things like, are circuits blowing? Are we having more failures because of this? And it's often really important to monitor that from the call site, not from the service that's serving the request, right? Like you need to monitor success because success is sort of determined from the caller, not from the responder, for a whole host of reasons, not the least of which is it's real hard to like monitor your own deadlines. So we'll end up having to monitor that kind of stuff like from our front door APIs or from these other services. Those are really like, those are our bread and butter. We have those set up for like every one of our services. It's part of like putting a new service into production. That we don't do that often, but when you put a new service in production, it's got to go out with a whole suite of these tools. We have some internal tooling to make that easier to get at it and all that. Because, you have to hook it into like the Phoenix router, which is like pretends to be a plug, but isn't a plug. And it's weird. So yeah. And we have people who work directly with like, I'm forgetting the name. I always want to call it the EEF. No, the EFF. Is it the EEF? Did I get it right? The Erlang.
The EEF. Erlang.
The EEF.
Foundation.
I get so confused. Anyway, we have a couple of people who are on staff at Bleacher Report also are on the the monitoring and observability group as part of that. And so we work with them too and collaborate with the different projects like telemetry and stuff like that that's going on there to push some of that back into the world.
Okay. I think that's probably a good note to stop on. Of course, Chris, I want to give you as much time as you need, provided it's not very long, to plug anything, any of your projects, your companies, anything. Shameless self-promotion time. Now is your chance. Social media where people can find you, how to get involved with your projects, etc. Go ahead.
Yeah, sure. So I'm Keith Lee on GitHub. That's like the place I'm most active these days. I have a blog at keithlee.io. I write there occasionally. I'm trying to write more. We'll see if that actually happens. I am on Twitter, but I check it basically like once every month. So odds are not good that I'll see it. But if you want to drop me a note on there, you're more than welcome to. And it's just at Chris Keithley on Twitter. Yeah, I also, like we mentioned earlier, I'm also part of the Elixir Outlaws podcast and do that. And it comes out every so often. We talk about Elixir-y things and just like other sort of just shucking and jiving about just life stuff. So you can feel free to give a listen to that if you're in the podcast life. Yeah, that's kind of me. That's everywhere.
And we're not competitive because Wizards and Cowboys have no cinematic universe overlap.
Yeah, that's my favorite crossover of the century. Is Wizards and Cowboys. That was my favorite D&D alternative. Wizards and Cowboys. I think that's a Savage Worlds mod.
If it's not Savage Worlds, it's super generic. GURPS. That's what I want. GURPS.
Oh yeah. There you go. Well, that's like what Savage Worlds is kind of based off of, right? Oh wait, hang on. We got to do this. Is this going to be tabletop podcast now?
I think Eric already runs the tabletop podcast. Yeah, and also I have no idea what you guys are talking about. This has been another episode of Elixir Wizards. Thank you so much, Chris Keithley, for joining us today. I am Justice Epen, joined by my co-host, Eric Ostrich, and we'll see you next week. Thank you all for listening.